Greetings. This is it. I think this is your last video. Well, it's the second to last video because you've got a TED Talk to watch too. And this is going to be pretty short. So anyway, welcome to your second to last video, or the last video by me, so you don't have to hear me talking to you this way anymore. Test of correlation in RStudio. All right, so far, we've done all this statistics stuff, estimated proportions, means, differences in means. We've tested hypotheses about means and differences in means. We've learned 2 tests of categorical data, those chi-square tests, right? So what we're going to learn today is we're going to learn about scatter plots, calculating a sample correlation coefficient for 2 numerical variables, and testing the population correlation coefficient. And you're actually going to do some of these things. So if you want to, you could get RStudio up and running, but you can just wait. You can pause the video and you can go do that. So anyway, that's what we're going to do. All right, so scientists and engineers often collect data in order to determine the nature of the relationship between 2 quantitative variables. For instance, what's the relationship between temperature and a tree's sap flow, which is important for my ancestors who came from Vermont and raised like maple trees for sap, for syrup. What is the relationship between the amount of study time a student plays Among Us and their GPA? And what is the relationship between shoe size and the number of broken bones that a person has? So, I mean, some of those seem ridiculous, some of them seem reasonable, right? And so that's what we're looking at. All right, so suppose to do a scatter plot in RStudio, suppose we have a sample size n on 2 variables, x and y. So we have like xy, like you think of shoe size and broken bones, shoe size and broken bones of a second person, and so on. Scatter plot gives a quick visual about the relationship between x and y. I think you guys have already done some of these in RStudio back in the day. And in this one, you'll see this literally is sap flow and temperature in Celsius. And notice it's really clear that temperature and sap flow have a negative relationship in this scatter plot. All right, so correlation is a measure of a linear relationship between an x and a y. And a sample correlation coefficient, it's like the symbol is R, and the population correlation coefficient, which would be the true relationship between those two variables, is called rho, which is like an R, lowercase rho. Kind of looks like a P without like the little tag up here. All right, and a correlation is always between -1 and 1. So I mean, definitely get this written, these scatter plots drawn in your notes for sure, and these symbols so you know which one's which. All right, a positive linear correlation will be points that sort of, as x increases, it looks like y increases. In this case, this, like the way these are scattered, this would be an R of about like 0.4. A negative correlation, this should be a negative 0.4. This would probably be a correlation of negative 0.4, not positive 0.4. And then this one would be like nearly perfect positive linear correlation. So R would probably be about 1. Perfect negative linear correlation would have R equal -1. So notice what it's measuring as it gets closer to 1 and -1. It's really how much those points fall exactly in a line. All right, how grouped together they are. It's not the slope of the line. Okay, so R is not the slope of the line. It's just how closely they group to a line. And then you could have like points all over the place, like in this example, where there's no correlation. And by the way, that could mean that X and Y are independent. It doesn't necessarily mean that, though. Okay, so it just means as X increases, that increase has no effect on what Y does, and vice versa, and maybe R would be close to 0 in that case. Interestingly enough, something like this, like advertising, dollars spent, and demand, this would also have an R of about 0. So although there's obviously a really strong relationship between X and Y, it's not a linear relationship. So the correlation we're studying is just linear correlation. This is a really famous economics example that maybe you've seen, right? Like where X is the amount of dollars spent on advertising and Y is the demand for the advertised product. That's called the law of diminishing returns. As advertising dollars increase, demand increases for a while until the market gets sick of the advertising, and then, those amount of dollars don't create more demand. Actually, it creates less demand. All right, so there are things like that happen, and there's like a lot of variables that just have relationships that aren't linear. Okay, they might be related by a curve, and that's not what we're talking about here. We're talking about just linear relationships. So here's your prep problems. Name 2 variables related to your own behavior that have positive linear correlation, that might have positive linear correlation, like as I do this more, then this happens more. 2 variables related to someone else's behavior that have negative correlation. Okay, so as that person does this more, then this goes down, like this other thing goes down. Name 2 variables that probably have no linear correlation. So come up with those examples and put that in your prep work. Don't use examples that have already been given. I bet you can just think of things from your life or from other people's lives. By the way, we've already done scatter plots. Scatter plot is just plot of X and Y. They have to be linear variables, or not linear. They have to be numerical variables. Okay, so think of numerical variables X and Y. And correlation, to just quantify the size of that relationship, you just do COR of X and Y. Okay, so here's a quick example. This is actually from the homework of this section. In a study of ground motion caused by earthquakes, the peak velocity in meters per second and the peak acceleration in meters per second were recorded for 5 earthquakes. The results are in the table. Okay, so here's what we had for velocity. Here's what we had for acceleration. Larger peak acceleration measurements have been related to larger amounts of damage, by the way. So that's like in earthquakes, you're looking for these numbers to be large. So anyway, what I did is I made a velocity vector and an acceleration vector because I didn't have this data in a spreadsheet. And then I plotted this. This visual is a little hard to see. There's only a few points. It's only 5 points, and you can see them. They're up here, and then there's one way down here. All right. So it's kind of hard to tell if this is a very strong relationship when there's such a small data set. But look, when I did correlation, it's a negative 0.88. It's actually a really strong relationship. Okay, the scatter plot seems to show a negative tendency, and this correlation also shows a pretty strong linear relationship. However, it's a really small sample, and that value, which was 2.925, or something like that, 3.25, yeah, it was really 2.92, 3.25. It should be this one, right, for velocity and acceleration. It could be an outlier, so we should be unsure about this result. How do we know if a relationship we think we see and the extreme correlation value we read are significant? We could test it. I know this is outside of the viewing window, sorry, but what we want to do is test whether this correlation is significant or not. So we can do a correlation test, and it'll test whether the correlation is actually positive or not. All right, or negative or not. So a test of correlation is really easy to do in RStudio. We want to see if this small sample contains significant evidence of a negative correlation in the whole population of all earthquakes. we will still use our four-step process. Sorry, we really use a 5-1 because we do the decision and the interpretation separately. So I'll clarify that in class. But our H0 is that the correlation for the population is greater than or equal to 0 versus H1, which is the correlation is less than 0. Remember, we saw a sample correlation less than 0, right? And we want to see if that's enough evidence to reject this. Okay, so this is our alternative. It needs to agree with H1 or our sample data. So we do the test in RStudio, which is core test VA, and alternative less. And this was our T. Notice we're back to T distribution, and there's the p-value, 0.02, right? That's great. So the p-value is less than 0.05, so we reject H0 and conclude H1. All right, so that would be our step 4. We can conclude that earthquake velocity and acceleration have a negative relationship, linear relationship. Okay, so they really are negatively related. All right, so our core test, right, this RStudio script, core.test, xy alternative could be greater, less, or two-sided. Two-sided is the default, by the way. If you just want to see if the core, by the way, this two-sided, this equal to not equal, just means is there no correlation or is there a correlation? So if you're just trying to see if there's a correlation, you could do a two-sided test, and then you could explain it later. All right, so what I want you to try to do is with the 2020 class data, so call that up. For each of the following pairs of variables, create a scatter plot, calculate the correlation, that's just COR, right? This is plot, this is COR, and then test the appropriate hypothesis using the 5-step process. All right, if you use a 4-step process, that's okay too. All right, so for prep. Okay, so by the way, real quick, if you just want to call up that data set, we've been working on a different data set, but the other data is probably still in there. If you just type 2020.class.data, it'll pop up. And then attach 2020 class data, it'll reattach all the variable names. So you can get it really fast if you still have like your RStudio open. But let's see if shoe size and age are related. Okay, so do a scatter plot, right? Calculate the correlation, that's COR, and then do the core dot test on those, and then see if cars and siblings have a linear relationship. All right, that's all we're going to do. Next time, we'll do just one quick problem like this. These are not hard to do, and I'll clarify anything from this that you are confused about. And then we're going to go on and start doing linear regression, which I think you'll enjoy. All right, that's all. Go watch the little TED Talk video. It's short. Okay, thanks. Bye.